Section 1.2 talks about exponents and radicals. This is a quick review. There are a lot of small details we got to pay attention to. So first things first, exponential notation. We say if b is any real number and n is a positive integer, then b to the n is b multiplied by itself n times. The number b is called the base and n is called the exponent. We're going to have examples on everything that I'm showing you just in a bit. If b is a real number other than 0, then b raised to the 0 is always 1. So any number other than 0 raised to the 0 power is 1. And if n is a positive integer, actually that works for real numbers as well. It doesn't have to be a positive. It doesn't have to be an integer. But for now, if it is an integer, then b to the negative n is 1 over b to the n. And rules of exponents, we have a few of those. So if you multiply two exponentials with the same base, you simply add the powers. If you divide them, you subtract the powers. If you raise an exponential to a power, you end up multiplying those powers. And if you divide, you subtract. Oh, we already said that. If you have a fraction raised to a power, so if the base is a fraction, then the power belongs to each term in the fraction. And if you have a fraction raised to a negative power, you could switch the power from negative to positive by taking the reciprocal of the fraction. So, example 1, evaluate or simplify the expression. Evaluate normally means get a numerical answer. Simplify means get an expression, like you have variables or something like that. Well, negative 3 to the second power. Here the base of exponent 2 is negative 3, so it's negative 3 that gets repeated twice. And we know that 2 negatives multiplied will leave a positive, and 3 times 3 is a 9. Versus, if I look at b, negative 3 to the second power, well, the power, the exponent of 2 here, belongs to the base of 3, not negative 3. So it's only 3 that get affected by that power. If they wanted to include the negative, they would have used parentheses, but they didn't. And we know if you multiply a negative and a positive, the answer is a negative 9. Right? And if I multiply two terms with the same base, I write a single power, and I write a single base and I add the power. 7 plus a negative 5 is a 2, and 4 squared is 16. And if I see a fraction raised to a negative power, I could change the negative to a positive and take in the reciprocal, and that would be 4 squared over 3 squared, and that would be 16 over 9. Alright. Here, if I really think about this, that's really negative 3x squared multiplied by negative 3x squared. I'm sorry. I meant cube. Well, negative times a negative is a positive 9, and x cubed times x cubed, when you multiply terms with the same base, you simply add the powers. And if I multiply multiple terms, you could do this one at a time. You could do the whole thing one shot. You're at a single base. If you decided to do it two at a time, 3 plus a negative 5 is a negative 2. Again, it's recommended that you do it all one shot if you're really comfortable with this. And negative 2 plus 7 is 5. And here, I multiply this. You could do this in any order you want. You add the powers. And here you want to be careful. Well, you could play along and say, you know what, I know what that is. That is x. And you take 2 minus 4, which is a negative 2. If a problem says simplify, you're not supposed to leave your answer with negative powers. And if you remember, oops, I'm sorry. That's right. What do you know about negative powers? If I take a quantity raised to the negative power, that's simply 1 over x squared. There are a few ways you could do that problem. We really want to start doing things this way because we want to save time. And I see a fraction raised to a negative power. I could make that a positive for a price of taking the reciprocal of that. And that's really 3 times 4, that's a 12. 2 to the 4th is 16. And x, 2 times 4 is 8. Next problem up. I know that this is z to the 5th over y squared raised to the 4th power. That is z to the 20th over y to the 8th. And here I'm looking at y to the 15 over z to the 10 x to the 10, z to the 10. So basically distribute that in. And if I just copy that and be patient, z is one of a kind. Y to the 15. Since you're dividing, you subtract. 15 minus 8 is a 7. And x to the 10, oops, I messed up. Z to the 20th divided by z to the 10, you subtract the powers. 20 minus 10 is a 10. So, a bit tedious, not hard, just too many rules. You really want to digest those because that's something that's never going to leave you alone. And again, you could do this so many different ways. You have many options of doing this since you're not adding and subtracting. Really, order of operations don't really come into play. You could say, you know what, let's get rid of that first. By, again, many ways you could do that. There, first step. Second step, you could say, well, let's see. A 2, one of a kind, an R, one of a kind. But here, I could move the negatives. I've seen students do that. There are a couple of options you have. You could say take 5 minus a negative 2, that works as well. And since that's negative, I move it down. I've seen students work it this way, and it seems to make a lot of sense to students. Whatever works. And that would be x, 5 plus 2 is a 7. 3 plus 7 is a 10. And if you distribute that power in, that's x to the 28 2 to the 4th, that is 16. 4 times 10 is 40, r to the 4th. Again, there are other ways of doing this problem. Any of those will work. Now, we need to get the principal radical out of the way. If I have a positive number, then the square root of that number is always positive, or it could be 0, depending on what that number is. If I have a positive number or 0, the square root of a positive number is positive, the square root of 0 is 0. So, pretty much in general, this is called the principal radical. If you take the square root, 4th root, 6th root, 8th root, the even root of any quantity, that's always bigger than or equal to 0. What radicals do, they undo exponents. So a square root is asking, what did you square? What did you multiply by itself to get this number? A cube root is asking, what did you multiply by itself 3 times, or what did you cube to get this number? Now, one main use is that I could take a radical and write it as an exponent. The nth root of b to the 1, I could write that as b to the 1 divided by n. And once I write that as exponential, then I could use all the exponential rules and they apply accordingly. And the nth root of b to the n, I could say that's b to the n raised to the 1 over n. If I multiply the powers, that's what I'll get. Or I could say that is b to the 1 over n raised to the n. So you have a couple of options. You could write the problem this way or this way. And I'll point out each as we do problems. First things first, I'm looking at this problem, and this is asking, what do you multiply by itself to get 9? Well, a 3 or a negative 3. If you multiply 3 by itself, you get a 9. 3 times 3 is 9. And negative 3 times negative 3 is positive 9, except we just set up the principal radical, and we said an even index radical is always positive or 0. Even though negative 3 times negative 3 is positive 9, the fact that this is a square root, there's a 2 sitting there, the outcome can only be positive. Negative, even though it works, it's not allowed, not for us. And if I look at the square root of 18, well, there isn't a number that you multiply by itself to get 18, a rational number at least. So we say this is the square root of, and that's 9 times 2. As long as you're multiplying, what do you multiply by itself to get a 9? Positive or negative 3, we already agreed negative is not allowed. So that could clear the radical as a 3. And what I have left underneath the radical is a 2. And that's called an exact answer. And if I have 2 radicals divided, I could combine into a single radical. And that would be 1 over 4. Square root of 1 is a 1. Square root of 4 is a 2. Unless I made a mistake. I did make a mistake. I should have went the other way here. I should have said, look, what do you multiply by itself to get 16? By the way, the mistake was 8 over 16 is really 1/2. And we're not there yet. You can't leave, so if a problem says simplify, you can't leave a radical in the denominator in general. You can't leave your answer with negative powers. So, the square root of 16 is a 4. The square root of 8, that is really 4 times 2. This radical clears as a 2, and you have a 2 left. And we know that 2 divides 4 2 times. and that would be my final answer. Same deal here. I look at this problem, say, wait a minute, well, the denominator, the square root of 25 is a 5, and 12 is 4 times 3, and we know that 2 is the square root of 4, and you have a radical, a 3 left underneath the radical, and that would be